Hi children, good morning. Welcome back to our session. What is our topic children? Motion and time. Is it? So in the previous class we have seen a small video regarding to the motion. Have you seen? Yes. So today's our topic is about measurement of time. How we are going to measure the time? What measuring, ma'am? Just to see in the watch and tell it. Is it? Nowadays it's okay. But previous or not, how they used to tell the time? How, ma'am? How we used to tell? Yeah, that one only. How? By seeing of the sun. Sun rises in the east and sets in the west. So, if it comes by seeing of the shadow of one of the object, they used to tell the time. Is it? Then after that we got the sundial. By using of that sundial we used to tell the time. Is it? Yes. And after that slowly we have improved and we got the watches. And first the watch, if you observe that, we will be having one like this, like a spoon, it will be moving, tick tock, tick tock, tick tock. Have you observed that? Yes, like that. Watches we call clock. We call it as pendulum clocks. So nowadays also few of the houses it will be having that pendulum clock. Then what is that pendulum? One of the well-known periodic motions. So periodic motion, it will be the exact going, coming. Going, coming, to and fro motion. We call it as the to and fro motion. So one of the well-known periodic motion is that of the simple pendulum. Then here is one of the picture children. This one, it has this one, we call it as a metallic bob. That metallic bob, it has tied to the one of the thread. Okay, to show the oscillations. So here what it has happened, I have taken towards to the A, and when I am going to leave it, it goes to O and it is going to move towards to the B. So once again it comes back, moving, coming, like our swing children. We will play the swing now. So one will drag like this and then push. So you are going front and coming back. That is called as the to and fro motion. Simple pendulum consists of a small metallic ball suspended from a rigid stand by a thread. So, for this we have tied the thread and this metallic one we call it as a bob. The metallic ball is called as a bob. B-O-B, we call it as bob. Next, how it will be moving? To, fro. To, fro. To and fro motion of a simple pendulum is an example for a periodic or a oscillatory motion. We call it as periodic motion or we call it as the oscillatory motion also. To and fro motion of a simple pendulum, we call it as, it's the example for periodic or the oscillatory motion. So the time taken by the pendulum to complete one oscillation is called its time period. It's called its time period. So how we are going to measure the time? Time is measured in seconds. So it's the unit for the time. Seconds. After that we will go for minutes. Then we are going for hours. Is it? Yes. So the time is measured in seconds. Then if you want to tell one word, example, 2,13,460. 2,13,465. This number is there. If you want to say that number, suddenly we can say no. It takes a little bit time. So first we have to recognize that numbers and then we have to calculate the units. Is it? Then times like this we have to say. Then we have to tell that 2,13,465. That means each and everything it takes a particular time. What about our heart children? Heartbeat. So how much time it takes? For 1 minute. The pulse of the normal healthy adult, it beats 72 times in a minute. Is it? For 1 minute it is going to beat for us 72 times. How many times? 72 times. That is, for 1 second how many times it is going to take? 12 to 10. Is it? So, for that means it varies. For the small kids it will be very less, and adults will be, and those old people. So, for 1 second it is going to beat 12 to 10 or 10 to 12 times it is going to beat. That means we are calculating the time here. Not only the time, children. Here we are going to calculate the speed also. For example, if you are running, you are reaching the goal. So, with how much speed and what is the time it has taken, we are going to calculate it. Is it? So, for that, make a triangle and mention D, S, T. What do you mean by D? Distance. What do you mean by S? Speed. What do you mean by T? Time. So, if you want to calculate the distance is equal to these two. Cover this. What we are having? S, T. S, T. So, what we have to multiply. Distance is equal to speed into time. Next, if I want to find the speed, S is equal to D upon T. That means distance divided by the time. Then, if I want time, time is equal to, close the time, D upon S. So, distance should be divided by the S. So, this is one of the small logic that means easily to identify how to find out what it has given. If distance is given, S into T. If speed is given, D by T. T is given, D by S. Have you heard about the sand clock, children? Have you seen the sand clock? Yes, I'll show through the picture of the sand clock. So, here up the sand is there, down it is the empty bottle. Up to down, how much time it takes. By that we can calculate the time and as well as the speed also. So, this is about the sand clock. And have you about the Chintamani? Where it is? In Delhi. So, this is also one of the monument, one of the place for us to know the time of that. And water clock, children. Have you seen the water clock? See the water clock. So, by this we can know the timings. But nowadays we are not using. What's the time? Yes, ma'am, this is the time. Or by looking of the wall clock, we can tell the time. So, by this also we can say the time by using of some of the devices, and these are the few formulas to find the speed, distance and time. And by this, let me end up our class. Watch a small video regarding this. Okay? Thank you, children.
And time. The purpose of the DST triangle is it can help you remember the speed, distance and time formulas. First, the way to remember how to lay out the letters in the triangle is that they are in alphabetical order. D, S, T. Then add dividing lines between them. The reason for these will become clear later. You find the formula you need to use by simply covering up the letter of what it is you need to find. If the question asks you how far something travelled, you cover up D. If you are asked how fast, cover S. And for questions asking how long, cover the T for time. Here is how you should use it. To find the formula for speed of an object, we cover up the S. This then shows that distance is over time, or distance divided by time. For distance of an object, cover up the D. This leaves S and T. As they are next to one another, this shows you need to multiply them. Now for time an object has travelled. Cover up the T. You are left with distance over speed, so you need to divide distance by speed. Let's apply this to some questions and work through an example of each. A car takes 6 minutes to travel 5 miles. What is its speed in miles per hour? So, for this question, we need to find the speed. So we cover up the S on our triangle, which indicates we need to divide distance by time. The car has travelled 6 miles, and our answer will be in miles per hour. So we do need to convert our minutes into hours first. Convert the 6 minutes by dividing by 60 like this. Now we can work out our answer from 5 divided by 0.1, which equals 50 miles an hour. Here is our next question. An aeroplane flew at 400 miles per hour for 3.5 hours. How far did it travel? This time it's asking how far, so we are looking to find out the distance here. So, by covering the D, we are left with speed times time. That gives us 400 multiplied by 3.5, which equals distance travelled of 1,400 miles. Here is our final question. Brian is planning to cycle 84 kilometres to a hotel for an overnight stay. He cycles at a constant speed of 24 kilometres an hour. How much time will it take him to get there? So, on our triangle, we need to cover up the T. This shows us we need to divide our distance by speed. That's 84 kilometres an hour divided by 24. That gives us 3.5 hours. So, that's how the DS